Let's look into the last lab program, that is 8th lab program. Design Verilog program for implementing various types of flip-flops such as SR, JK and D. Note: CLK is clock, RST is the reset input and Q is the output signal. When RST value is 1, Q will remain as 0. During simulation, right-click on the RST variable in wave window, select force constant, then type the value 1 and click on OK. Right-click on the CLK variable in the wave window, select force clock, enter leading edges as 0, trailing edge as 1, period as 1 US and click on OK. 3. Run the simulation. 4. Right-click on the RST variable in wave window, select force constant, then type the value 0 and click on OK. 5. Run the simulation and verify the output signal. Let us Verilog program for D flip-flop and SR flip-flop. Before writing the program, let us understand what is D flip-flop. A D flip-flop is a better alternative that is very popular with digital electronics. They are commonly used for counters and shift registers and input synchronization. In the D flip-flops, the output can only be changed at the clock edge, and if the input changes at other times, the output will be unaffected. The changes of the state of the output is dependent on the rising edge of the clock. The output Q is the same as the input and can only change at the rising edge of the clock. Let us write a Verilog program for D flip-flop. Module DFF D, Q, QB, CLK, RST. Input D, CLK, RST. Output Q, QB. Reg Q, QB always at clock begin. If RST Q less than or equal to 0, reset else begin case of D. 0 is to Q less than or equal to 0, 1 is to Q less than or equal to 1, end case, and assign QB equal to not Q and end module. Now let us understand what is SR flip-flop. This is the most common flip-flop among all. This simple flip-flop circuit has a set input S and a reset input R. In this system, when you set S as active, the output Q would be high and Q would be low once the outputs are established. The wiring of the circuit is maintained until S or R go high or power is turned off. As shown above, it is the simplest and easiest to understand. The two outputs as shown above are the inverse of each other. The truth table of SR flip-flop is highlighted below. Now let us look at the program of SR flip-flop. And now let us look at the output for both the programs, SR flip-flop and D flip-flop. In SR flip-flop, when set is given to 0 and reset is given to 0, then clock is equal to 0 and reset is equal to 1. Then Q is equal to X and QB is also equal to X. In D flip-flop, when D is equal to 0, clock is equal to 0 and reset is equal to 1, then Q is equal to X and Q bar is equal to X. Now let us understand what is JK flip-flop. Before understanding the JK flip-flop, let us look into the definition of JK flip-flop. Due to the undefined state in the SR flip-flop, another flip-flop is required in electronics. The JK flip-flop is an improvement on the SR flip-flop where S is equal to R is equal to 1 is not a problem. The input condition of J is equal to K is equal to 1 gives an output inverting the output state. However, the outputs are the same when one tests the circuit practically. In simple words, if J and Q data inputs are different, that is high and low, then the output Q takes the value of J at the next clock edge. If J and K are both low, then no change occurs. If J and K are both high at the clock edge, then the output will toggle from one state to the other. JK flip-flop can function as set or reset flip-flops. Now let us look into the Verilog program of JK flip-flop. Module JK flip-flop J, K, Q, QB clock reset. Input J, K, clock reset. Output Q, QB R is G, Q, comma QB. Always set CLK begin if reset Q less than or equal to 0, else begin case of J comma K. End case and assign QB is equal to not Q and end module. The output of the JK flip flop is shown in the screenshot. Thank you.